Week about the need to fix those kind of issues. He's the side can do better.
Hello
We're
everyone.
excited, as he said, and score goals because we built the team for that, but we have to be more solid.
I request to everyone, please mute yourself. Hello, Dinesh, my screen is visible now. Okay, thank you. Hello, Dinesh.
Yes, Magni, please go ahead.
My screen is visible now.
Your screen is visible, but it is some white or pink color kind of thing.
Okay, okay, let's ignore it. Okay, no worry. Okay, so hello everyone. Good morning, good evening. So today we have a special webinar on the groundwater flow modeling. Okay, we are going to start this webinar today. It's great to see so many people here. I first of all I request to everyone, please mute yourself so that during our webinars we cannot get any disturbance and all. If you have any questions, anything, we have a short question answer session at the end of this webinar for the 10 minutes also, or you can ask your question in the chat box. Our team will help you from there directly. Okay, so sorry for the delay. Now it's great to see so many people here from, I think, different background is there, from the different engineering students, research scholars, and working professionals also. From the different locations are there. Okay, so welcome to our exclusive webinar on response of shallow foundation in soft soil, considering the groundwater variation using the Plaxis software. My name is Mayank. I am the co-host for today, and I'm thrilled to have the Dr. Dinesh Malviya, our Plaxis expert with years of experience of the geotechnical experience and leading this session today as a speaker. So in our webinar today, we are going to cover the specific interesting topic that required to understand the impact of the groundwater level in changes on the foundation performance, also improve the foundation design accuracy under soft soil and groundwater conditions. So this all the important facts today you can be learn with using the Plaxis software also, and that help you in specifically once you started your designing projects and do any kind of the research, it definitely will help you. Now, before that, just quickly introduce to the company. So we are basically just give the short introduction about our organization. So at Pixu Learning, we are an edtech startup company focusing on helping the engineering students, research scholars, and professionals to gain design industrial ready skills, and we provide online courses and certification training programs on industrial 4.0 softwares mainly that deal with the various industries like in geotechnical, structural, aerospace, automotive sector, and other various oil and gas and other various sectors also. So we are using the different softwares like in Simula, Abacus, NCs, Plaxis, GeoStudio, Rock Science, and many other software that we have in the bunch of training programs we are offering to help the engineering students and professionals to skill themselves to work on these various of these important software that in demand currently. Our mission is to simple to bridge the gap between the classroom learning and the real world application so that you can learn, you can train, you can research also, and you can work more effectively. So Pixel Learning is here to support your growth, solve the complex problems, okay, and open up the new opportunity to your future also. Now, uh, in the this webinars, before we move ahead, please keep your microphones muted to avoid any background noise and all. If you have any questions, feel free to drop them in the chat box. We will make sure they are addressed during the question answer session also at the end of this webinar. Now this webinar is being recorded also, and the link will be sorted with you afterwards. So don't worry if you miss any points and all. Now let me introduce to our speaker, Dr. Dinesh Malvi also. They have the 7+ years of experience in the Plaxis and dealing with the slope stability, groundwater flow, modeling structures and all, soil structure interactions, foundation, rock mechanics, tunnelings, and other prospect also. So through this session, we will get to learn more about in the Plaxis software, how we deal with the groundwater conditions and all. Now, without further delay, let me just introduce about today's speaker, Dr. Dinesh Malviya. So yes, Dr. Dinesh ji, you can start the session now. Yeah.
Yeah, thank you very much, Mayank ji. And I'm happy to deliver a webinar on this very auspicious topic called foundations. Before that, let me share my screen first.
Yes, please.
I hope my screen is visible to all and I am audible very well.
Yes, yes, correct. You are audible. Screen is also visible.
Okay, so our today's topic or talk will be focused on the responses of shallow foundations subjected to some groundwater fluctuations using our finite element based software called Plaxis 2D. So this webinar is being conducted on the aegis of Pixel Learning. So before starting, let me give you a brief introduction about the software. Since Plaxis is having 2-dimensional as well as 3-dimensional both packages, but today we will be focusing on the 2D package of Plaxis software. It is a finite element based software and it is widely used for most of the cases for analysis of deformation and stability in the geotechnical engineering projects. Why I am telling it to be specifically because in Plaxis 3D you are having more insight about some other aspects also, maybe some of the peculiar soil structure interaction also you can conduct some deformation pattern in a more realistic way. So this software is a bit different and it is widely used for the analysis of deformation, which include and which is being observed in most of the geotechnical engineering problem, such as foundations, tunnels, and many more. It can model several model of the soil behavior. Most of the time, we are relying on some of the basic soil models, such as Mohr-Coulomb model, but it is beyond it. We can model using some of the advanced model, such as the hardening soil model or these things. It is a robust package specifically developed for 2-dimensional analysis of geotechnical problems. Its advanced constitutive models are user-friendly interface, allowing engineers to accurately predict the soil response. which helps engineers to predict the soil behavior, to predict the foundation behavior, to predict the slope stability assessment, and many more. Also, apart from the deformation pattern, it can be used for stress distribution, stability performance, and several others. So, with this small background of the software, we will be having today's topic, which will be focusing some of the learning outcomes, in which we will try to understand the fundamentals of shallow foundation behavior under fluctuating groundwater condition, and then we'll learn how to set up the model of shallow foundation in 2D version of Plaxis using realistic soil constitutive models, and try to explore the influence of soil rock stiffness, which used to represent the flexibility of the soil in terms of flexible and rigid foundation. Also, the very important factor called groundwater fluctuations are also being tried to assess, because we know that with the variation of groundwater, the pore water pressure used to develop, consequently the total stresses get changed, because total stress is equal to effective stress and the sum of pore water pressure. So if groundwater fluctuation is there, then the pore water pressure fluctuation will be there, total stress fluctuation will be there. Consequently, it is going to affect the shear strength of the particular media. Do we have any message? No message? Okay. So after that, we will interpret our results, including the deformation pattern and force distribution, and also try to gain insight into soil structure interaction, the importance of stiffness and the groundwater control in design, and try to apply advanced Plaxis tools for more accurate and reliable foundation design.
Yeah. Okay.
I think now it is okay.
Yeah, it's better now. Yeah.
Okay, so we'll try to discuss some of the input parameters, input procedures, which will include the geometry, material mesh generation, boundary condition, initial static conditions, construction stages, calculation, as well as some of the report generation. So when we talk about geometry, we'll be discussing about the representation of soil models, soil stratigraphy, maybe some of the uh, material properties which is related with structural elements such as pile foundation, or in our present case, raft foundation. So this will be including some of the distinct soil layers, structural objects, construction stages, and loading. And model must be sufficiently large so that boundaries do not influence. So see, the boundary condition is also one of the important parameters which should be taken into account. And then the main geotechnical geometric components of these are point, line, and cluster. We'll see it. Now, when we talk about boundary condition, the deformation problem are of two types: condition consisting prescribed displacement or prescribed force based. So all boundaries must have one boundary condition in each direction so that it may satisfy all the things. So the prescribed forces are equal to 0, and then it is if it's a free displacement. And some of the fixicity depending upon the fixed foundation or maybe in vertical or lateral direction of the flow, and it may be depending upon the version of the software, it shows that roller support or fixed support in maybe parallel or cross edge lines. Then we need to define our material properties. So material properties may include the material properties of the constitutive soil models which we are using, maybe the unit weight, maybe the elasticity. Okay. And after that, we need to define the material property of our structural elements like pile foundations or raft foundation or tunnels, whatever we are. So we need to define all these things with having the adequate material strength so that we can, and while defining the material property, we should try to be as realistic as possible so that we can have a close result in comparison to the field one. Then, after doing all this mesh generation, definition of material properties, definition of boundary, the constitutive models, once all things are cleared and checked, then we will define all the things in a several construction stages. Let's say, for example, if I tell you, like in field, what happens? Let's say there is a soil medium, then we need to apply our foundation. We need to construct it. Over the construction of that foundation, we need to construct the buildings. So these are in stages. It is not like that in a single day or a single minute it is going to happen. Okay. So we need to define all the construction stages, and once it is being done in a holistic manner, then we will try to analyze our results. So if I talk about the soil models which are available, so there are several different soil models which are available in this Plaxis software, like linear elastic, Coulomb, hardening soil model, disjointed rock, and many more. So we'll try to discuss this hardening soil model, which is very much popular for modeling.
Hello, Dinesh. So, is it possible like some of the background noise be coming from your background currently? So, is it possible to remove that noise?
I think it is not now. Maybe. Is it fine now?
It's still about some noise be coming from the background actually.
Okay, let me check it.
We are really sorry that participants like this happens currently. It takes 30 minutes also, and we can't deliver the webinars now. So let us just allow us the 5 minutes only. We can address this issue.
Is it fine now?
Yeah, now it's better. Yeah.
Okay. Thank you very much. So we will try to discuss about some hardening soil model, and input parameters obtained from the hardening soil model are most of the time from the triaxial test, whereas the other basic soil model, which is Mohr-Coulomb model, the soil material properties are being obtained. Maybe it can be fetched from the direct shear test, which is very common. But when you move towards any of the advanced soil model, you need to do advanced soil testing also. Sometimes if you're moving from hardening soil to hardening soil small strain material model, then you might be needing some of the advanced shear test called cyclic triaxial test. So for hardening soil model, there are several basic characters of this model, such as stress dependent stiffness according to a power law, which is being shown by input parameter M, and plastic straining due to primary deviatory loading is represented using the parameter E50 reference. So what is happening in Mohr-Coulomb model? We are defining the stiffness of the material using one E value, whereas when we move towards more advanced model, there are several values of E which is to be taken care. As in case of hardening soil model, you can see E50, REF, E reference, OED, which is odometer representing the plastic straining due to primary compression, and the unloading reloading part of the elasticity is being taken care by EUR. So in most of the cases, you'll find that E50 is equal to EOED, and EUR is 3 times the E50. So several failure criteria as like Mohan Kalam are such as cohesion, angle of internal friction, and dilatancy angle is also being common in this also. So moving forward with this background knowledge of the software, we'll try to go to our problem, today's problem. So for foundation, there are two types of foundation. Most of the time it is either shallow foundation or deep foundation. So you can see that if you see this foundation, the width and the height, the width and uh, is quite high in comparison to the depth of the foundation. Whereas in the second case, if you see that the depth of the foundation is quite high in comparison to the width or periphery of the foundation system. So this is the basic difference. If the depth is quite high, then it will be categorized into deep foundation, whereas if height or width is quite high, then it will be considered to be shallow foundation. The other thing which we need to take care is about the stress or influence zone. These are shown by different lines. So let's say if some small loading is being, let's say this is 10 kilonewton, then some stress zone will be developed. If we increase to 20, then other will be increased like this. So this influence zone, let's say this influence zone is showing corresponding to the ultimate capacity of the foundation. So you can see this line is within the soil domain, which is perfectly fine. But if the boundary conditions are not well defined, then the stress zone or this envelope may go outside of this. So which shows the poor consideration of boundary condition and eventually lead to the reflection of these stresses, which is not desired. So these things we should keep in mind. And for today's problem, we are considering heterogeneous soil layer because we are considering some soft soil material. So the clay layer is on the top and up to some 8 meters. So with this realistic soil data, we'll just move to a software interface. So first of all, you will be finding this kind of interface. So for starting the project, we'll do it like this. And we can write the name. Let's say we may write the foundation. And in comments, you may write anything for the removal. For our case, we are writing ground water table considerations, right? So because anything just for your marking what you want to understand with this. After that, we'll go to model. So we are having two different type of model called plane strain or axis symmetry. Most of the time, if your problem is having symmetric geometry or symmetric material properties, then you can go with this axis symmetry just to save your time. Because if the geometry or problem is symmetric, then the responses will also be in symmetric phase. Whereas for plane strain problem, in which the two dimensions are quite high in comparison to the third one, we used to take the plane strain. Mostly this is used for the slope stability assessment, because in this you will find that these are the third direction is quite high. So since we are not much worried about the computational time and those things. So we are considering our plane strain kind of thing. And here you can define your element using 6 noded or 15 noded elements. So for our case, today we will be defining 15 node. It is like when you are considering your 15 noded elements, that means the discretized continuum of each element will be having 15 nodes. That means it will increase your computational time. It will affect your accuracy as well. So after that, we'll define our model here. First of all, we need to discretize our soil. So let's say 50-meter length and some minus 30-meter of depth. Let me check here. Oh, we are having up to 50-meter. So we will be taking the depth up to 50-meter. Right. Because in field condition, you will be having this kind of realistic soil data. Now we'll try to add the material property. The first layer is soft soil, soft clay, we may say, which is being modeled using the Mohr Coulomb, and the drainage is selected to be like this. After that, we'll see that the unit weight is in unsaturated condition is 15 kilonewton per meter cube, whereas for saturated condition it is somewhere 18 kilonewton per meter cube. And the elasticity is somewhere 3400 kPa. Correspondingly to this. The depth dependency has been considered. I will tell you what does that means. After that, we will be going to this, considering so the coefficient, this is kx and ky are coefficient of permeability in both directions. Like this. So this is the property for the first layer. The second layer is sand layer, which is now defined using the hardening soil small strain model, which is an advanced soil model. One thing we just keep in mind, whatever value I will put it, it will be equal to this and 3 times of this. So this is a relationship. Can you see? So E50 is always equal to E odometer, and the unloading loading is 3 times the E50. And E50 you can take from the axial test. So small train shear modulus is 80,000 kPa in our case. So our angle of internal friction is here. That means the cohesion is not there. So it is purely cohesionless soil. And there is a relation for defining this xi, which is dilatancy angle. If it is greater than 30, then the dilatancy angle will be angle of internal friction minus 30. So what will be the output? It is 1. So this is having quite higher coefficient of permeability, since sands are having better coefficient of permeability in comparison to clay, which is very well established. Now the third layer. So we'll take all the data from here. So the last layer is of deep sand, and the unit weight are corresponding to 17 and 21 for unsaturated cases. We have selected and now it is a bit more dense, so higher angle of internal friction will be there. Okay. Now we try to define the material properties. Uh, so the second layer is 8 to 22, third is from 22 to 35. Okay, very well. And the other one is the up to 50. Okay, perfect. So now we'll try to install or assign the material properties. One thing I need to focus is, you can see that water table is at the ground level, right? If you want to move it here, just change the head. So with this, you can do the fluctuation in water table, which significantly influence the performance of the foundation. So for our case, we are considering somewhere here, maybe 5 meter, somewhere here. Okay. So you can see this discretized soil model is here. I hope till now you are having some idea how to model this soil layers. Do we have any questions? Okay. So after this, modeling your heterogeneous soil media, we need to define our foundation also. So there are two approaches to define your shallow foundation, either using the volume raft or the plate element. So if you are interested to model it using the volume, then you need to define the material property as well. So we are considering it to be M25 grade of concrete. So 25 km per meter cube and 25. So with this, you can now model your foundation. Let me change the color bit. Okay. Go to structure. So if you are interested to model your foundation using the volume element, then you can use this soil polygon option. Otherwise, there is other option of creating this using the create plate element. So for this, maybe some thickness. Now, no material is assigned, just assign the material shallow foundation. So you can see it is here. Now you can apply certain load also, or maybe settlement also. So corresponding to settlement, you will be having certain okay. Now we'll go to mesh. During meshing, you should also consider 2-3 points since it is a foundation. So if you see, the coarseness factor is 1 for each and everything. But this is foundation. I want to have a better definition of the elements. Then I will do like this. . like this. Also, if you're interested in capturing the complex soil structure interaction, you can apply the create interface here. Now do some finite element mesh generation. So Plaxis allows you to discretize your soil continuum in several different type of mesh type. It will give you 5 different type of mesh. Very fine is the mesh quality in which the discretization will be of smaller level. Now see the water table which we have considered earlier, it is here. Now in stage construction, the first one will be the in situ stress generation. We are not going to do any addition of foundation or anything, but in second stage we'll try to add our shallow foundations. Okay, so when we come from here to here, now we will activate our soil model. Just change it to shallow foundation. So now you will see this shallow foundation material property is being assigned. You can use this thing. Interface and all is being activated. Now you can apply certain loads. Maybe 20 kilonewton for the first time. Next, incremental order, because what does this load increment shows? That maybe the construction is in progress or some activity is going on, accumulating the weight. Sixty, maybe okay. So now load is there. So since we have selected the displacement, okay, then we will apply the displacement of initially 2 mm. But there are two approaches, load based or okay. So first of all, we'll activate these and minus 2e. So this is equivalent to 2 mm. Okay. After that, we'll select some point to plot our load settlement curve. can select any point. You can switch off the stresses and node to see this. Let me take you to one more point which I need to address is, since we have selected some coarseness around this foundation, so you can see small and uniform sizes, whereas the element sizes where the coarseness factor is high is like this. So we should focus to have certain this kind of mesh quality around the structural elements such as foundation or tunnel which we are going to construct. Okay, let's take some point. Before starting, you need to save your file. Okay, and you will use this button to start our calculation. Okay, so this green tick shows that this has been completed successfully. Okay, let's go to output. So you can see so this load settlement curve you can plot using this option, either in cumulative, or if you are interested plot for single, you can apply like this. So you will find that this much load is being carried up to this point. And if you're interested, you can see all this using this. So for 12 mm settlement, it is around 272.216 kilonewton meter load. So you can use this tabular option also for load settlement. And from contour also you can see so as the stresses in terms of displacement are varying, you can see the stress profile and all everything gets varied. You can check for each and every step. Also, if you're interested in calculating the bending moment and all in this foundation, then use this option of structural forces in volume plates. From here, you need to identify, since our case is of shallow foundation, we'll try to detect it, which one is shallow foundation for this problem. And let me make it more large. Yeah. So you can see it. If you want to find out axial forces, you can see the distribution of axial forces along this foundation, shear forces, as well as some bending moment. So all the things you can, like, already we have discussed about this force distribution, the load settlement curve. Even if you're interested in calculating some of the stresses, so you can very well see it. Like, you can see it, some pore water pressure distribution. This line shows the magnitude. However, you can calculate the total principal stresses also in this form. So you will find that the stresses are quite different when compared with these places. So the stresses are quite concentrated just below this foundation. Okay. So this is all what I have prepared for today regarding the foundation design subjected to this thing. And the other approach is the plate element, which I'm not going to cover today, but you can model your foundation using that also. Uh, this is for monitoring your overall deformation contours. You can use this tabular form just to have a better record purpose maybe. Okay. So yeah, this is all which I have prepared for today. If you have any questions or query, please feel free to ask. Anyone? Okay, so many messages. Okay, okay, okay. How do you determine the equivalent displacement per stage? The equivalent displacement, see, the modeling of the foundations are either from the load-based approach or the displacement-based approach. So if you are, maybe let's say for example, you are designing your foundation in Indian condition, then you need to follow the Indian standard code. So where they have defined that the foundation settlement of 10% of raft width is uh, can be taken as the ultimate capacity of that foundation. So let's say if you're having 5 meter of this thing, so maybe 50 mm or somewhere there, you can have that equivalent displacement to be maximum, and you can split it into maybe small segment, maybe 5 to 10 to 15, 20, 30, depending upon how much time you are having for your particular problem. I know they are different actually. You can see that we have applied a displacement of 2, 4, 8 and in incremental order. Basically these are corresponding to some load values which we have taken out from the load settlement graph. Can you share the properties? Yeah, already I have shared it. You can take it from here also for your practice purpose. Also, you can get the several soil profile data from any of the field uh, related maybe research articles or those kind of things. They are quite widely available. So we have seen the effective stresses also. Uh, Someone is asking about simulation of a retaining wall. Yes, of course, we can do a different session for that. How can we validate the results? And see, for validation of the result, it is very much important to have the accurate data to whom we want to validate and also the consideration of boundary conditions. So mostly for a shallow foundation or raft foundation, the lateral boundaries are assumed to be 5 times of the raft width, whereas the vertical boundaries are considered to be 3 times of the this uh, geometry of the foundation. Yes, you can remove it, just subtract the overwater stresses due to the foundations, and the leftover will be just due to the applied load. Just you need to download the, see what you can do, like we are having some output files as already in the Excel format. So that overburden, you just download all the Excel format and just subtract the previous one. So the one which you will get after subtraction will be the original stresses for that particular case. That you can do by doing some exercise with the Excel orientation of the results. Yes, you can use it. Directly, you can, it will be pretty difficult because it shows the backlog load with them also. So that is why this facility is there to simulate your results with, in consideration with the previous one also. Okay. So if we have no more questions, then maybe the session could be handed over to the moderator.
Hello, yeah. Thank you so much, everyone, to attend this webinar. I hope you would like to, you are be having interested to joining the Plaxis learning, and join in the future courses also to learn in a detailed way about the software and all. It's very helpful for you. I would like to submit your feedback also about this webinar, how it's been, it's helping to you, becoming any kind of like help you can need it for from this webinar also regarding these topics and regarding the Plexis software also. We also offer the Plexis live training programs and the live courses and the project assignments also. So that also be helpful to you. So if you are be interested to join in the live training for the Plexis software in detail way, you can also visit our website and click on our in the chat box also about the link for the Plexis training program. You can also be join our live trainings and any kind of the project assistance if required also. We can also be contact to our team, so we can definitely be help to you. I think thank you so much for everyone now to joining this webinar. Just requested to you again to submit your feedback. How's this webinar be helping to you? in terms of like what we will be learning from there, so that we can in the future also we can continue this webinar series also. And you can also be add the which kind of topics you want to cover in our next webinar also. So you can also be write that topics in the chat box, so we can plan the next webinars on that particular topic also. If you have anything more questions or anything, uh, yeah, sure, sir. We can also be share the recordings to all the participants who registered in our event, this event also. So we can definitely share the recordings also.
Yeah, I think we have pretty much questions and we have tried to solve in this short span of time. And as the moderator has said, if you are
Mm.
having more questions or doubt, please feel free to ask him, and you can join our live training session for more entertaining lectures, having covering broad area of the geotechnical engineering aspects.
Yeah, Raja, can you please share the our website link and Plexis training website link also? In our website, we have directly add the WhatsApp chat button and live chat button also. You can directly reach out to our team also to asking further any questions, or if you need any discussion for regarding this software or the any geotechnical related subject also you want to learn something, you can directly touch with us also. I think we covered the so many questions also, but there are some of the questions also be left. So yeah, Samuel and some other persons also. So we can definitely address your questions also in the next webinar, and you can also be type the topic also you want to add in cover in the next our webinar series also. We can definitely cover those topics also. I hope you will like this webinar. Now it's time to just end of this webinar now. So thank you so much, everyone. We can share the recording also, and you can directly reach out to our website also for any kind of the help or any kind of the services you want. Okay, thank you so much, everyone. Thank you. Yeah, bye.
Okay, thank you very much. Have a great day ahead.
Okay, thank you. Thank you, Desi. Thank you. Bye. Yeah, good day.
Thank
Bye.
you very much.